can we hide this thing? Oops. Okay, hash tables. Today's objectives, by the end of this lesson or session, we'd be able to gain a better understanding of hash functions and hopefully make hash tables our BFF. So hash tables come in many different names. In Java, it's called hash maps. Of course, JavaScript, it's objects. Dictionaries in Python, and then unordered map in C++. And knowing this data structure is an absolute must, because as we've seen already in our software engineering bootcamp, we use it a lot in databases, in versioning for Git. Even a popular website that I'm using to sign off documents in real estate, DocuSign, uses it. And then also when we're creating passwords to a website, and that's in the security version, security portion. So it's used in versioning and security and also databases. So what is exactly a hash table? Basically a hash table is, for example, if you have pineapples, right? And we have 10,000 pineapples, we can store this pineapple value into memory, and it creates an index. It creates a key, and that key is equivalent to an index to where we can find the value in memory. And this is done by what we call hash functions. So if we were to store the pineapples, it's going to go through a hash function. And this hash function is going to do what it needed to do in that little conveyor. And then it spits out a key. And that key goes into an address in memory. And here, this is very simple. But basically, it also stores the value. So it actually stores the key and the value of whatever element that we're trying to put in memory. So what is a hash function? Let's see it in action right here. So this is the hash generator. It's just gonna, I'm just gonna show real quick why and what it's doing. For example, if we were to do a hello here and put it through the hash function, it's gonna generate a hash code right here. And so that's basically what the hash function is doing. And there's different characteristics or rules that it goes with, and we're gonna go through in a few minutes. But if we were to actually change it to hell, it also changes different. So different input is gonna have a different value output for the key that the computer uses. There's also different kinds of hash generators here. If you're interested, just look them up. And so with the hash function actually doing this, there's different rules that it follows. And let's go through them. So the hash function, this is very special because, for example, if we have, kiwi, pineapple, eggplant, pepper, if we put this through the hash function, it actually outputs what we put in. So it only gets that output from our input, right? So it gets that information from there. And then it returns an output fewer than it accepts as an input. So for example, if we put 8 input in there, it's only gonna give us 6. So there's no way of us knowing, what our input was. And then it always returns the same output for the same input. I forgot what this means, but yeah, I totally forgot. Okay, and then next thing is that this emoji factory is a one-way street. So um, if we were to guess what was inputted into into the hash function, we can't because it's only one way. So there's no way for us to trace back exactly what the input was, because remember also in number 1, if we put 8 of them input in there, it's only going to output as 6. So it's kind of hard for us to actually trace back our way to see which ones we input. And then, yeah, like I showed earlier, if we were to change one letter into the hello word, then it's going to give a completely different output. And then, so basically, as you know, we can tell from this rules that it's saying, it's like that is why it's really used in passwords. Like for example, if you were to input a password, it's kind of hard to guess that because you kind of have to really trace where or what they put in, the user put in as a password. And this is really used very well in cryptography. So if you guys look into that, that's really cool. It explained a lot about how the computer communicate and, the keys that the computer has, and how hackers have a hard time hacking into, messages between computers. It's really, really interesting. Okay, so now time complexity. The time complexity for a hash function is basically O of 1, most of them, because we have a key and a value property. Let's see what we have here. Okay, so if I were to look for, if we have this user with these value properties here, key value pair, if I was to look at user age, user.age, that's 1, so that's actually an operation of O1. And even the bark, even if there's a function within that and we use that, that's also O1. So we can see how, it just goes into where it needs to go right away in memory. So that's actually O1 time complexity. Alrighty, next is, so if this data structure is so great, why aren't we using it all the time? Let's see why. So if we were to put 4, it's gonna, find that value in memory, insert it into something else. We do 5, insert it somewhere. 99, 4 maybe. See, now with 4, it inserted it in the same memory place as the other 4. So basically, we have a collision. And that is why we're not always using it, because of collision. Because remember, when we do, our memory always have limited values, right? We can always have extended memory. So once that value here is used up, it kind of gets it to the same memory value as the other ones that's already used. Okay, so in our GA module, we had this as an example of collision, right? So Lisa was already there, John was there, but then when Sandra came along, she also was assigned to the same memory address, and that could be a problem. And so there are different solutions for collision, and one of them, as we can see here, is kind of like a linked list. It's very familiar to us, so that's one of the things that we can do to actually avoid collision. One of the things that's also special about the hash function or hash table is that it's no order. Um, you know, compared to an array, if you do put a value or an element into the memory, it's gonna have a block of memory. But with objects, it's not gonna have an order. It just finds whichever one is available. And so it's called unordered, basically the hash table, except in the new versions of the JavaScript, they came up with the map, which is kind of useful for ordering the items in there, and then the sets as well. So here it says a set is like a hash map, except it only stores keys without values. So what are the solutions for collisions? Open addressing, close addressing, proving, or chaining. And on our GA module, it tells us about what linear probing is. Basically, if it's no longer available, then it just jumps and finds an open space. And then there's also quadratic probing. It's just a formula that it follows to input, you know, our element into memory. And then there's double hashing as well. So with the hash table, we've seen that it has faster data access. And basically, you can optimize it more than an array, and their time complexity is 1. Does anybody have any questions or anything? No? Okay, we'll keep going. Hash implementation. Okay, so in JavaScript, there's also already, you know, a built-in method for us to create an object, but that's not fun, right? We're great developers, so we can see how we can actually create an object ourselves. So if we were to create a class of hash table, you're gonna wanna have the size of that, and then of course put in the data in there. And this is actually how you can create a hash key by yourself. So you can length through whatever key you put in, and then you just kind of do the car code at I, and then you know you can do your own operations on it, and then it should return a different value every time you do that. So this one I provided in the end. You can kind of, you know, try to explore it if you wanted to, of how this thing works, because it's probably better to actually explore it yourself than me explaining it. And then there's the popular Google interview question about hash functions. Basically, it wants you to get the first recurrent character on that. And like I said, I'm not gonna go through this right now for the convenience of time. but I have the solution at the end of this slide. So if you want to go through this and practice your Google greatness, then go ahead and do so. Okay, hash tables versus array. So yeah, the search, insert, and lookup, like I said, is kind of straightforward. It's a one. Searching an array is ON because you have to go through the entire array and look for that index. And then insert and delete is also ON. And so it's a little bit better than an array. So reviewing the hash table has faster lookup, fast inserts, also have flexible keys, but it does need resolution for collision. And then it's unordered, right? And then slow key iteration if you were to iterate through the key. Oh, interesting information. As we've been saying that the object is actually unordered, Python actually has made dictionaries ordered by default. So in Python, the difference between an array and hash table are less. And here's the information if you're interested in that. And then resources, this is just, explaining more a little bit about hash function. And oh, there's a great class here that talks about it. And then this one right here is if you want to be really great at solving problems using hash tables, then this is a 20 hashing technique. And then, yeah, that's the solution to the current character. So basically it was 2 days worth in the JA module, but I kind of condensed it a little bit and just went through faster with it. So that's about it. I feel like right now I just want to try to solve most everything with hash. So, do you guys have any questions?
No, that was really good. Thanks, Jen.
Yeah, you're welcome. And I was looking at the problem that we have earlier. It's actually very possible to compare two objects. So that's probably what I'm going to be working on.
Cool.
That's it.
You're good.
Thank you.